disciplines spending on cloud computing. So let's see AWS, Amazon Web Services, Azure, Microsoft Azure, and Google Cloud Platform. So I will explain cloud computing in very simple language, even if you are a beginner. So we will understand what cloud is, why companies use it, and how AWS, Azure, and Google Cloud work in real life. So, first we will understand what cloud computing actually means. Then we will see why cloud is needed and what problems it solves. After that, we will after that we will discuss cloud services models like AAS, PaaS, SaaS. Then we will deep dive into AWS, Microsoft, Azure, and Google Cloud Platform. We will compare them, see real world use cases, talk about career opportunities, and finally we will have a session. Then let's see next. So, what is cloud computing? In very simple words, cloud computing means using computers, storage, and software over the internet instead of using over your own machine. So, for example, on your laptop, it is stored on Google's cloud servers and you can access it any in the same way companies today do not buy physical servers. Instead, they rent servers, storage, and databases from cloud providers like AWS, Microsoft Azure, and Google Cloud Platform. And the best part about cloud computing in this, you pay only for what you use. No extra cost, no maintenance headache. That's why cloud computing is used by almost every company today. So here what is cloud computing? Then next is why cloud computing. So in very simple words, cloud computing means using computers, storage and software over the internet instead of your own machine. For example, Google Drive, you are not saving data on your laptop, you are saving it on Google's cloud. So, similarly, companies don't buy physical servers anymore. They rent servers, storage, and databases from cloud providers like AWS, Azure, and Google Cloud Platform. And the best part is you pay only for what you use. Then next is cloud service models. So now the next question is why do we need cloud computing? So next slide is why cloud computing. So let's understand how things worked earlier. So earlier, if a company wanted to run an application or store data, they had to buy expensive physical servers, then set up their own data centers, manage electricity, cooling, and space, then hire hardware and infrastructure engineers, plan capacity years in advance. So this was not only very costly but also inflexible. For example, if a company bought 10 servers and suddenly needed 20, they had a they had to again invest huge money and time. And if the servers were not used fully, the money was simply wasted. So this is where cloud computing solved the problem. So first we will see scalability. With cloud computing, companies can increase or decrease resources anytime. If traffic increases today, they can add more servers in minutes. If traffic reduces tomorrow, they can remove them. There is no need to plan everything in advance. Then next is cost effective. So cloud is cost effective because there is no upfront hardware cost. Companies don't need to buy servers or maintain data centers. They only pay for the resources they actually use. Then this is especially useful for startups and growing companies. Then next is high availability. So cloud servers are designed to run 24/7 without downtime. So cloud providers store data across multiple data centers. So even if one server fails, another one takes over automatically. So this ensures high availability and reliability. Then fourth one is a global access. So cloud services are available globally. A company in Indian and make it accessible to users in the USA, Europe or anywhere in the world without setting up servers in every country. So because cloud is scalable, company today uses cloud computing from startups to multinational organizations. That's why cloud computing has become a core foundation of modern IT system. Then let's move to a very important concept in cloud computing, which is cloud service models. So cloud services are mainly divided into three models based on how much control the user gets and how much responsibility is handled by the cloud provider. These three models are IaaS, PaaS, and SaaS. Let's understand them one by one with simple example. So first one is IaaS, infrastructure as a service. So which stands for service. In this model, the provider gives you basic infrastructure such as virtual machines like servers, storage, networking. Here you have full control over the server. You decide to which operating system to install, then what to configure security, how to manage updates. So for example, AWS EC2, then Azure virtual machines. Think of us like renting an empty house. The house is ready, but you decide everything inside it. So, as is commonly used by system administrators, DevOps engineer, companies migrating from on-premise servers. So, it's all about infrastructure as a service. Then second one is PaaS, which is platform as a service. So in this model, the cloud provider manages runtime environment and scaling. As a developer, you only focus on writing code. You don't need to worry about server setup, software updates, infrastructure maintenance. For example, Google App Engine and Azure App Services. Think of past like fully furnished apartment. You just move in and live. No setup needed. So application developers, startups and rapid application development. Then next is SaaS, which is software as a service. So in this model, you don't manage anything at all. You simply use the software through the internet. For example, Gmail, Zoom, Salesforce. You don't need to install software, update versions, or manage servers or storage. Think of SaaS like staying in a hotel. Everything is managed for you. You just use the service. So SaaS is used for end users, businesses, non-technical users. So in short, as infrastructure as a service, which is maximum control and more responsibility, then PaaS, which is platform as a service, less control and more convenience, then SaaS, which is software as a service, no control, complete. So if you want full control, choose as. And then if you want to just develop application, then choose PaaS. And if you want to simply use software, then choose SaaS, software as a service. So understanding these models is very important because real companies use all three models depending on their requirements. So this is all about cloud service models. Then deployment models. So now let's understand cloud deployment models. So, deployment models explain how and where cloud infrastructure is set up and who has access to it. Companies choose a deployment model based on security, cost, compliance, and business needs. There are four main deployment models, which are public cloud, private cloud, hybrid cloud, and multi cloud. So, first one is public cloud. So, in the public cloud, cloud resources are shared among multiple users, but data remains secured and isolated. These services are owned and managed by cloud providers like AWS, Microsoft Azure, Google Cloud. And public cloud is cost effective, easy to set up, highly scalable. So most startups, small businesses, and learning environments use public cloud. For example, a startup hosting a website on AWS EC2 is using the public cloud. Then second one is private cloud. In this model, cloud infrastructure is dedicated to a single organization. It can be hosted on premise or hosted by a third party cloud provider. Private cloud offers highly security, then more control, better compliance. Private cloud is mostly used by banks, government organizations, and healthcare companies. For example, a bank using its own private cloud to store sensitive customer data. So this is all about private cloud. Then move to the hybrid cloud. So now let's talk about the hybrid cloud, which is very popular in real companies. Hybrid cloud is a combination of public and private cloud. Companies keep sensitive data in a private cloud and public applications in a public cloud. This gives flexibility, better security, cost optimization. So, for example, a company storing customer data in a private cloud and running its website on a AWS. The last one is multi-cloud. So, multi-cloud means using more than one cloud provider. For example, AWS for compute, Azure for enterprise apps, then Google Cloud Platform for analytics and artificial intelligence. So companies use multi-cloud to avoid vendor lock-in, then improve reliability, choose best services from each provider. So large enterprises and global companies mostly use multi-cloud strategies. So public cloud is affordable and scalable, then private cloud is secure and controlled cloud, which is best of both worlds. Then multi-cloud is flexibility. That's why big companies usually use hybrid or multi-cloud models, not just then. Now let's start with the first and most popular cloud platform, Amazon Web Services, commonly known as AWS. So AWS is the world's largest cloud service provider and it was 2006 by Amazon. At that time, Amazon realized that the same infrastructure used to run its own e commerce business could be offered as a service to the companies, and that's how AWS was born. Today, AWS is used by millions of customers worldwide, ranging from small startups to large enterprises. Some very well known companies that use AWS are Netflix, Amazon, Airbnb, many government and enterprise organizations. This tells us one important thing: AWS is a trusted at a global scale. So, why AWS is so popular? One of the main reasons AWS is a popular because it offers hundreds of cloud services. These services cover almost everything, which includes computing, storage, databases, networking, security, artificial intelligence, machine learning, analytics, and Internet of Things. Because of this wide range, AWS is very popular and flexible. However, this is also the reason why beginners sometimes feel AWS is a complex. There are many services, many options, and many configurations. But once you understand the core services, AWS becomes much easier to work with. So, global infrastructure. AWS has data centers across the world called regions and availability zones. This allows companies to deploy applications then achieve high availability, reduce downtime, and handle millions of users at the same time. That's how platforms like Netflix stream videos without interruption even during peak traffic. So, who should learn AWS? AWS is ideal for cloud engineers, DevOps engineers, system administrators, backend developers. AWS skills are highly in demand and widely accepted across industries. Now that we understand what AWS is, let's talk about some of the most important AWS services that are widely used in real world projects. AWS has hundreds of services, but you don't need to learn everything at once. If you understand these core services, you already understand 70 to 80% of AWS basics. So first one is a Amazon EC2 virtual servers. Let's start with EC2, which stands for Elastic Compute Cloud. EC2 allows you to create virtual servers in the cloud. Instead of buying a physical computer or server, you can launch a virtual machine within minutes. With EC2, you can choose operating system, Linux, Windows, select CPU, RAM, and storage. Start or stop servers anytime. Scale up or down based on traffic. For example, if your website suddenly gets more users, you can increase server capacity instantly. And when traffic reduces, you can scale down and save money. This is why EC2 is the backbone of many cloud applications. Then on S3 cloud storage. So next is Amazon S3, which stands for Simple Storage Service. S3 is used to store files and data in the cloud. You can store images, videos, documents, then backups, logs. And S3 is highly secure, highly durable anywhere in the world. A very common real world example is Netflix. Netflix uses Amazon S3 to store huge video files and EC2 to deliver those videos to users globally. Ensures fast streaming with minimal downtime. Then third one is the Amazon RDS, Relational Database Services. So now let's talk about RDS, which stand for Relational Database Service. RDS allows you to run databases in the cloud without worrying about installation, updates, backups, maintenance. So AWS manages all of this for you. RDS supports popular databases like MySQL, PostgreSQL, Oracle, SQL Server. So developers can focus on application logic instead of database management. Then fourth one is the AWS Lambda, serverless computing. Now this is very interesting service, AWS Lambda. Lambda allows you to run code without managing servers. You just write your code, upload to Lambda, AWS runs it automatically when needed. You are charged only when your code runs. This is perfect for event-based tasks, API backends, automation jobs. This concept is called serverless computing. No servers to manage, no infrastructure headache. So real world example which is Netflix. To connect everything with a real example. For example, Netflix uses EC2 for computing power, S3 for storing video content, then other AWS services for scaling and security. That's how Netflix streams content smoothly across the globe, even with millions of users online. Next, let's talk about Microsoft Azure. Microsoft Azure is a Microsoft's cloud computing platform and it is extremely popular among enterprise level companies. One major reason Azure is so widely adopted is its seamless integration with Microsoft technologies. If a company is already using Windows servers, Active Directory, MS SQL Server, Office 365, then Azure becomes the natural cloud choice for them. So Azure works very well corporate and enterprise environments, especially where Microsoft products are already in use. Then why companies choose Azure? So Azure is preferred because strong security and compliance, excellent support for hybrid cloud, then easy integration with on-premise systems. So enterprise grade identity management using Azure Active Directory. This makes Azure ideal for large organizations, banks, and government projects. So, real world companies using Azure, many big companies rely on Azure. For example, LinkedIn runs on Microsoft Azure. Samsung uses Azure for cloud services. Many IT services companies use Azure for. Now let's look at some important services provided by Microsoft Azure. Azure offers hundreds of services, but I will explain the most commonly ones. So first one is Azure Virtual Machines. First is Azure Virtual Machines. Azure VM is basically a virtual computer in the cloud. Instead of buying a physical computer or create a Windows or Linux machine in Azure, choose CPU, RAM and storage. Start or stop it anytime. Companies use Azure VMS to host websites, run applications, test software, and deploy enterprise systems. For example, a company can create 100 virtual services in minutes instead of waiting weeks for physical servers. Then second one is Azure Blob Storage. So blob storage is used to store large amounts of unstructured data such as images, videos, documents, backup files. And it is highly scalable, very secure, cost effective. For example, if you upload photos to cloud-based app, those images are often stored in a blob storage. And third one is the Azure SQL database. Now let's talk about Azure SQL database. This is fully managed relational database service. That means you don't need to install SQL Server. No manual backup or maintenance. Microsoft handles updates and security. So developers just focus on data and queries, not database administration. So, for example, e-commerce website store customer data, order and payments using Azure SQL database. Then fourth one is Azure Functions. Azure Functions is a serverless computing service. Serverless does not mean no server. It means you don't manage the server. Azure automatically runs the code, scales it, and only when code runs. For example, when a user uploads a file, an Azure function automatically resizes the image, sends an email, then updates a database. So no server running 24/7. You pay only for execution time. Then why Azure is a great choice? Azure is a great choice, especially if a company uses Windows servers, works with application, uses Microsoft products like Office, SQL, Active Directory, and Azure provides smooth integration, storage, security, and enterprise level reliability. So, this is all about Azure key services. The next one, Google Cloud Platform, which is GCP. So now let's talk about our third major cloud provider, Google Cloud Platform, commonly known. GCP is the cloud platform created and managed by Google, the same company behind Google Search, YouTube, Gmail, and Google Maps. So, what makes GCP special? GCP is especially famous for data analytics, artificial intelligence, and machine learning. Why? Because Google has been working with huge amounts of data for years, and the same technology that powers Google Search and YouTube is now available to companies through GCP. So, real world example, let me give you a simple real world example. Every time you search something on Google, watch videos on YouTube, or use Google Maps, all these services are running on a Google Cloud infrastructure. That means GCP is a highly scalable, extremely fast, and run at global scale. So why companies choose GCP? Companies choose GCP when they want high performance data analytics, advanced AI actions, cost effective cloud services, strong Kubernetes and container support. So GCP is also very popular among data engineers, data scientists, and AI ML professionals. So GCP and big data. One big strength of GCP is a big data processing. Google designed GCP for handling massive data sets, running real-time analytics, and processing streaming data. So that's why companies working with data-driven products prefer GCP. Then now let's look at some important services offered by Google Cloud Platform. These services show why GCP is especially strong in a big data analytics and machine learning and compute engines. First is a compute engine. Compute engine provides virtual machines on Google Cloud, similar to AWS, EC2, or Azure virtual machines. Using compute engine, companies can host websites and applications, run backend services, then deploy enterprise applications. The advantage of compute engine is a high performance and fast networking because it runs on Google's global infrastructure. Then cloud storage. Next is a cloud storage. Cloud is a cloud storage is used to store files, images, videos, backup data, and large data sets. It is highly scalable, very secure, accessible from anywhere in India. For example, companies store media files or backup data in a cloud storage and access it whenever needed. Then BigQuery. So now let's talk about one of the most powerful services in GCP, BigQuery. BigQuery is a serviceless data warehouse used for analytics. So what makes BigQuery special? It can analyze terabytes or even petabytes of data. You don't need to manage servers. You can run SQL queries directly on massive datasets. It is extremely fast. This is why BigQuery is widely used by data analysts, data engineers, and business intelligence teams. So Cloud function allows you to run small pieces of code without managing servers. This is called serverless computing. For example, trigger a function when file is updated, process data automatically, run backend logic without a full server setup. Developers pay only when the code runs, which makes it very cost effective. So why GCP is the best for data and ML? Because of services like BigQuery, cloud storage, cloud functions, strong AI and ML tools. So GCP is an excellent choice for big data, analytics and machine learning projects. Then AWS versus Azure versus GCP. Now let's compare the three major cloud platforms: AWS, Microsoft Azure, and Google Cloud Platform. Many beginners ask one common question: which cloud is the best? So the correct answer is there is no single best cloud. Each one each one is a best for different use cases. Let's understand this clearly. So AWS is the largest and most mature cloud platform in the world. Has the widest range of services, the largest global market share, very high job demand, and AWS is used by startups, enterprises, and product based companies. So, because AWS has so many services, it is very powerful, but it can feel slightly complex for beginners. If your goal is maximum job opportunities, strong cloud fundamentals, working with startups or global technologies, so AWS is an excellent choice. Then next one is a Microsoft Azure. Azure is extremely popular among enterprises and corporate companies. It is been known for strong interaction with Windows, Active Directory, MySQL, hybrid cloud support. So enterprises level security and compliances. Azure is widely used by IT service companies, banks and government large enterprises. If your background is Windows, Net or Microsoft tools, so Azure is the best cloud platform to learn. Then third one is a Google Cloud Platform, which is GCP. Now let's talk about Google Cloud Platform. So GCP is especially strong in data analytics, big data, artificial intelligence, and machine learning. Google uses the same infrastructure for Google Search, YouTube, Google Maps. They're extremely fast, highly scalable, perfect for data driven workloads. If your career interest is data analyst, data engineer, or AI ML engineer, GCP is a great choice. So, in simple, AWS is largest service range, highest demand, in Microsoft Azure, best for enterprises and Microsoft ecosystem. Then Google Cloud Platform, best for data analytics and artificial intelligence. So now an important tip for beginners. Do not try to learn all three code at the same time. Cloud fundamentals are similar, but services are different. Terminology is different. Tools are different. So my recommendation is start with one cloud. Master the basics. Do hands-on practical. And later you can switch or add another cloud easily. Then, now let's understand where cloud computing is actually used in a real life. People think cloud only for IT companies, but in reality, cloud is everywhere around us, even if you don't realize it. So, for web hosting, first is what? Web hosting. First and most common use case is web hosting. Today, almost every website is hosted on the cloud. Companies use cloud servers to house websites, run web applications, handle high traffic during peak times. For example, during sales like Amazon Big Billion Day, traffic suddenly increases. Cloud allows companies to scale and servers instantly, something that is impossible with physical servers. The next is mobile applications. Apps like Instagram, WhatsApp, Spotify, Uber, all of these apps use cloud services in the backend. The cloud helps in user authentication, storage, photos and videos, real time notifications, global accessibility. That's why you open Instagram from anywhere in the world and still access your data. So, data backup and disaster recovery. Another very important use case is data backup. Companies store their business data, customer records, application data on the cloud as a backup. If a system crashes or data center fails, cloud backup ensures no data loss, fast recovery, business continuity. This is extremely critical for banks, hospitals, and enterprises. Then, artificial intelligence and machine learning. Cloud plays a huge role in AI and machine learning. Training AI models requires high computing power, large storage, fast processing. Cloud provides Google platform GPUs and TPUs, AI frameworks, then scalable infrastructure. That recommendation systems, chatbots, face recognition systems. So run on cloud platforms. The Internet of Things. Another growing area is the IoT, Internet of Things. IoT device includes smartwatches, smart home devices, industrial sensors. These devices collect these devices collect data and send to the cloud. So cloud helps in storing IoT data, real-time processing, monitoring and analytics. For example, smart factories use cloud to monitor machines in real life. So popular apps are cloud-based to make it very simple. Apps like Instagram, Spotify, Netflix, and Google Drive are all cloud-based applications. Without cloud computing, these apps would not work at globally scale. So whenever you upload a photo, you watch a video, or use a mobile app, you are actually using cloud computing. So next is a cloud security basics. Security is one of the most important topics in cloud computing. Many people think that when data moves to the cloud, it becomes unsafe. In reality, cloud platforms are often more secure than traditional premises systems if used correctly. So shared responsibility model. Cloud security works on something called the shared responsibility model. This means security is a shared between two parties. First one is a cloud provider and second one is a customer, company or user. So cloud provider responsibility, the cloud providers such as AWS, Azure and GCP is responsible for searching physical data centers, servers and storage hardware, networking infrastructure, power cooling and physical access core cloud services. In simple words, cloud provides secure the infrastructure of the cloud. Then next is a customer responsibility. The customer's responsibility for securing data stored in the cloud, user access and permissions, password and authentication, application security, configuration of cloud resources. So even though data is on the cloud, how securely use it is your responsibility. Then encryption. One of the most important cloud security tools is this data is covered into unreadable format. Only authorized users can read it. The cloud provides offers encryption at rest stored data, then encryption in transit data moving over the internet. Then this ensures that even if someone accesses the data illegally, they cannot understand it. Then identity and access management. Another critical security feature is I'm identify and access management. I'm con- I am control who can access cloud resources, what actions they can perform. For example, admin can create and delete servers, developers can deploy applications, users can only see repos. This follows the principle of least privilege, meaning users get only the access they actually need. Then why cloud security is reliable? Cloud platforms regularly update security patches, follow global security standards, provide monitoring and alert systems. So that's why banks, government and large enterprises trust cloud platforms. So this is all about cloud security basics. Then now let's talk about one of the most exciting part of cloud computing, the career opportunities. Cloud computing is not just a technology trend, it has become a core skill required by companies worldwide. As more organizations move their systems to the cloud, the demand for skilled cloud professionals keeps increasing every year. So, first, cloud engineer. First role is a cloud engineer. A cloud engineer is responsible for setting up cloud infrastructure, managing servers and storage, monitoring performance, ensuring availability and scalability. This role is ideal for freshers, system administrators, anyone starting a cloud career. So cloud engineers work hands on with services like EC2, Azure VM, cloud storage, and networking. So DevOps engineer, next is DevOps engineer, one of the highest demand roles. Today, a DevOps engineer works on automating deployments, CI/CD pipelines, infrastructure as a code, then monitoring and performance optimization. So DevOps engineers use cloud platforms along with tools like Docker, Kubernetes, Jenkins, Terraform. These rules suits people who enjoy automation and problem solving. So solutions architect. So next one is a solution architect. Another important role is a cloud solutions architect. A solutions architect design cloud architectures, then cloud choose the right services, ensures security, performance, and cost optimization, works closely with clients and management. This role requires strong cloud fundamentals, then design and decision making skills, experience with real world systems, and it is one of the highest paying cloud roles. The next one is a cloud security engineer or cloud security specialist. Next is a cloud security engineer. Security is a top priority in a cloud environments. A cloud security engineer focuses on protecting cloud data, managing and access controls, ensuring compliance, monitoring security threats. With increasing cyber risk, this role is a become more critical and more valuable. So, global demand and salary. Cloud professionals are highly in demand globally and needed across industries. So, cloud skills are required in IT companies, startups, banks, healthcare, and government projects. This means cloud career offer long-term stability and growth. The next is a learning roadmap. Let's see learning roadmap. Cloud computing is one of the most in demand skills in today's IT world. It allows organizations to store, manage, and process data on the internet instead of local servers. To become proficient in cloud computing, we need a structured approach that combines theory, practical skills, and hands on projects. So, step one is learn basic networking and Linux. Before diving into the cloud, you must understand the environment it runs on. Most cloud services are built on Linux servers and knowledge to manage cloud resources effectively. So, key topics to cover networking basics, IP addressing, subnets, and CIDR. Then DNS, and CIDR. Then DNS, DHCP, and routing. Then firewalls, NAT, and security groups. Then TCP, IP, HTTP, HTTPS protocols. And second one is a Linux basics. File system and directly structure. Basic commands is ICD, mkdir, rm, touch, then package management, networking commands. So think of networking as the highways and the vehicle you drive. Without knowing the roads or how to drive, you cannot navigate the cloud. Then step 2 is to understand cloud fundamentals. So cloud computing provides on-demand access to computer resources over the internet. Understanding core concepts is critical before using cloud platforms. So key topics to cover cloud concepts, what is cloud computing, types of cloud, then cloud service models, then key services, then cloud advantages and practical activities which is watch free tutorials on AWS, Azure, and GCP basics, draw diagrams of IaaS, PaaS, and SaaS examples. Then third one is to create a free tier account. Hands-on practice is a crucial. Cloud provides offer free tiers to explore services without paying. Platforms for free tier, then Azure free account. So creating a free tier account is like getting a sandbox to practice. Then next is hands-on practice. Hands-on projects. So theory alone is not enough. Doing projects helps you understand real world scenarios and prepares you for job role. So projects for beginners are deploy a static website on AWS S3, then launch a virtual server EC2, then create a simple database, then set up networking and cloud automation basics. So okay. So, to conclude, cloud computing is not the future, it is the present. Organizations across the world are rapidly adopting cloud technologies to make their operations faster, scalable, and efficient. So, by learning cloud computing, you are not just gaining technical skills, you are opening doors to a wide range of career opportunities. From cloud engineer to DevOps and cloud architect roles, my advice is to choose one cloud platform, stay consistent in learning, and focus on hands on practice through projects. So, theory alone is not enough. Practical experience is what makes you confident and job ready.